going to continue our notes on exponent rules. We've talked about how to add them, how to subtract them. We've talked about when we have a zero power. So today we're going to look at what happens. Let's look at what happens when we need to distribute. So when we have a power to a power, we're going to, notice it has parentheses, we are going to simply write everything inside the parentheses to the exponent on the outside. So to the second power, we're going to write that 4 times. And then they've expanded it. 2 times 2 is 2 squared. 2 times 2 is 2 squared. So you've got this one, this one. You've got 2 times 2 is 2 squared here, and 2 times 2 is 2 squared. So 1, 2, 3, 4, 5, 6, 7, 8. So to the 8th. So we're going to also see, we've learned since 6th grade that when we have a number outside of parentheses, that means you need to distribute. So we're going to look at that also. So we can write this one, 5 to the 5th times 5 to the 5th times 5 to the 5th. Now you can use your addition rules that we talked about the other day. So this is really 5 to the 5 plus 5 plus 5. 5 plus 5 plus 5 is 5 to the 15th. Or we can write 5 to the 5 times 3, because 5 times 3 is also 15. Here, x to the 3rd, we would write that 4 times. And again, based on our multiplying by the same, with the same base, so we would say 3 plus 3 plus 3 plus 3, which we know is also 3 times 4. Either way, you're going to get x to the 12th. So our rule, when we have a power to a power, which looks just like the distributive property, is to multiply our exponents. Use the power of a power property to write. Okay, so here we need to say x 6 over 5 times, we'll put a 25 over 1, and we know we can simplify 5 and 1, so this just becomes x to the 30th. In like manner, we can also do that when we have a group inside our parentheses. So we talked about a while back, when you have a number with no exponent, this is really an exponent of 1. So this is really 2 to the 1st times x to the 1st, all to the 4th power. So this whole thing is in the parentheses, so this whole thing gets written 4 times. So then you have 2 times 2 times, so really 2 to the 4th and x to the 4th. Because you're taking and you're saying 1 times 4 on the 2 to the 1st power and 1 times 4 on the x to the 1st power. So if you don't have an exponent, I would suggest you write it. So we could write this, the whole thing, negative 4a times negative 4a times negative 4a. We need to write that 3 times. Or we can write negative 4 to the 3rd power, a to the 3rd power. If it asked you to elaborate and simplify further, then you could say negative 4 to the 3rd power is, we could also write negative 64 a to the 3rd. Just like up here, we could write 16x to the 4th, and it would still be correct. So this one has the exponents for us. So we have x to the 3 times 4 and y to the 2 times 4. So x to the 12th, y to the 8th, because we are just distributing, just like when we learned in 6th grade. So based on this pattern, if we have a whole group inside our parentheses, we will distribute our exponent on it. So this becomes a to the m times b to the m. So this is an instance. It's technically the same base because it's all in the parentheses, and when we expand it out, it now has different bases, which is why when you come back on the front here, we can't put these together, okay, because now they become different terms. C to the 1/2, D to the 1/4, all to the 8th. So again, C to the 1/2 times 8 over 1, D to the 1/4 times 8 over 1. So we can cross reduce. So I get C to the 4th, d to the second. So what do you think would happen if we had this same rule, but now instead of multiplying, we're dividing? So you're still distributing, but now we're going to distribute not only to the numerator, but also to the denominator. So a to the m over b to the m. So whenever you have an exponent outside of a parentheses, you're going to distribute it all the way through. So this one would be 3 times 1/3 over the 6 to the 1/3. And 1/3 of 3 is just 1. So we can write x, or we can write x to the first. And 1/3 of 6 is 2. So we can write x to the first over y squared. We could also just write x over y squared. These are the same thing. You don't have to put the 1. But for our purposes, to make sure we're distributing, it's probably helpful. We're going to pause there. And when you come into class, we're going to do a couple of examples together because that's kind of a lot of information to absorb.